Now, it is important to point out that not all functions actually have inverse functions. Every function will have an inverse. In other words, you're always going to be able to switch the x's and y's to get the inverse, but the inverse isn't always a function. Here's an example. Y equals x squared. Think about what the graph of y equals x squared looks like. It's a parabola. Something like that. If I'm going to find the equation for the inverse, I would switch the x's and y's, so x would equal y squared. And then when you solve that equation for y, you have to take both the positive and negative square root of x. And so if you're looking at that equation, you plug in a value for x, you're going to get two different values for y. So this result is not a function. Y equals x squared is a function, but it is a function that does not have an inverse function. Now, so we can categorize the types of functions that are going to have inverses, and they are called one-to-one functions. In a one-to-one function, each x is paired with one y, okay, that much of the definition of a one-to-one function tells us about the relationship being a function. If the function is going to be one-to-one, it will also be true that each y is paired with exactly one x. So to have a function, you have to have every x matched up with just one y value. In other words, the x's can't be repeated. To have a function that's one-to-one, it also has to be true that every y gets matched up with just one x value. And if we're looking at a graph, we can use something called the horizontal line test. To determine if we have a one-to-one function. It's a lot like the vertical line test, except that you're going to be looking at a horizontal line. So let me go back to the example that we started with. Our y equals x squared function. If I put a horizontal line on that graph, you can see that where I chose to put it, at least, that horizontal line is going to intersect that graph twice. So what we're seeing here, the horizontal line represents a y value, and there are two different x values that are paired with that one y value. So this function is not one-to-one. If you put a horizontal line on your graph and there is no way that that line touches the curve more than once, then you have something that is one-to-one. So an example of a one-to-one graph could look something like this. Maybe I've got the graph of y equals x cubed. We'll start with one that's really simple. If you think about drawing a horizontal line on that graph, I'm not sure you're going to be able to see that real well because I picked pink accidentally instead of red. But let me just, I can't stand that. We got to have something that's better. Red. There we go. Now, if I put that horizontal line on that graph, no matter where I position that horizontal line, it is only going to intersect that graph once. So this is an example of a function that is one-to-one. It is one-to-one, so it will have an inverse function. Has an inverse function. So let's go back to that equation, y equal x squared. That equation that represents a function that is not one-to-one. But if we restrict the domain and say that we're only going to consider that curve for values of x that are greater than or equal to 0, let's think about what we're talking about there. It's just the right half of that parabola, and that graph will pass the horizontal line test, so it is one-to-one. So we should be able to find the equation for the inverse. So same steps as before, switch the x's and the y's, so x is equal to y squared, but every place you have an x, you're going to replace it with a y. Every place you have a y, you're going to replace it with an x, including the domain x is greater than or equal to 0. When you're switching things around, you end up with y is greater than or equal to 0. Now, when I take the equation y squared equals x, and I take a square root of both sides, I'm only going to consider the positive square root because I am told in that line there that y has to be greater than or equal to 0. It won't ever be negative. So this, the graph of y equals square root of x, looks something like this. And that is a function. Now the other kind of neat thing here is that if you draw in the line y equal x on your graph, when you're looking at a graph of a function and its inverse, those two graphs should be reflections over the line y equal x. So if this is y equals x, a function, and the inverse are reflections over y equals x.